America was founded on the principle that all men are created equal. Later, we added women. But today we learned that not all grounds are created equal.
Okay, so I've been taking measurements with the ground hooked over here, but in theory, this should be ground here, but take a look at the scope.
Well, I'll be darned.
So that looks like that signal that I kept thinking I was seeing. So what I'm going to try to do now is I'm going to change our ground measurement to be this chassis over on the left here.
But how do you know that's true ground?
Well, everything's relative, right? So in a way, there's no real true ground. It's just everything is a voltage measured relative to everything else.
I mean, let's just dig a hole for God's sake. Stick it
so
in
now
there.
If I reference to here, measure here, right? Now we're seeing the negative, whatever that was. Okay, so just as a sanity check, I'm going to measure the plus 12 here. Yeah, there. Okay, so that's giving us our 12 volts.
Well, approximately.
Yeah, now, let's see. Okay, so what I'm going to start doing is I'm going to start taking measurements relative to that. So if we look at keep that in your mind, and what I'm going to do is I'm now going to switch the ground to the original power supply ground that was on the right relative to the camera. And now let me take a measurement.
Well, that's
a
definitely
good deal
different.
fuzzier, right? So if I measure that relative to the chassis, that's the card cage for the S-100 bus cards, it looks a lot cleaner.
Well, more or less.
Yeah, okay, so now this is the signal going into the base. Now, here's the signal reading off the collector.
I apologize for the shaky footage and both recording and using the
So there's still gunk on there. Here's the emitter. Now I want to see, what does this signal look like on the emitter if I change the ground reference to reference off the power supply on the right? Does this look jankier?
Oh, that definitely looks jankier.
Yeah, okay, so I think I should be careful about what I'm actually measuring things in reference to. That's the emitter there. In my last video, I made a mistake. This transistor is acting as a common emitter amplifier, so we should be seeing the signal on the base here at the collector, but inverted. I made a mistake in my last video. I said we should also be seeing it here as an emitter follower, but of course this is fully bypassed, so this should just be a DC value. Okay, I'm losing my mind. Watch this. So here's one part of the chassis, here's another part of the chassis. Now look at the scope. So I think there's just gunk everywhere. I don't trust anything anymore. So the main thing I do know though is if we see this signal at the base, but we're not seeing an equivalent signal at the collector. Okay, so I'm gonna do a diode check between the base and the emitter, and we read 0.535.
Yeah.
Okay. Now I'm going to read between the base and the collector, the BC junction.
0.645 volts. Oh, 0.6,
Yeah, something around there.
Around.
Okay. So I think that transistor is probably good. Wait a minute. Somebody in the YouTube comment section pointed this out, and I forgot about it until just now. We're at 100 millivolts per division. So that signal is only about 100 millivolts. Now turn that one back down. Okay, yeah. Okay, you're learning how to use the vertical controls. That's good. The people on the YouTube will be happy. That's 50 millivolts per division. So that's like 120 millivolts. It's going to need at least probably like 500 millivolts to turn on that transistor.
So it's not getting the proper voltage,
is it?
It's
not strong enough to turn on the transistor. Yeah,
Wait, what isn't strong enough?
The signal here. So the signal at the base here, that needs to be about 5 times what we're seeing to actually turn on this transistor. So I said this is a common emitter amplifier, but it's really better not to think about this as a linear amplifier. This is really just acting as a switch.
Oh, be sure to move your finger, Dad.
Oh, sorry. And this signal is not strong enough to turn on that switch.
We found our problem.
Yeah, so definitely there's something problematic. Take a look over here real quick. So I thought I had this contrast control all the way up. I'm going to fiddle with this contrast control while looking at it on the scope. Let's just look at, okay, so this turns the whole thing down.
We've got an average of 75-ish millivolts.
Okay, so this, when I crank things up here, okay, so this is me turning the contrast knob.
Okay, now that's weird. Every once in a while I get, why is there nothing much on negative Y?
Well, this really should be a digital signal, so it should either be a low value or a high value. So, and by lower voltage, I'm meaning here, and higher voltage, I'm meaning here. And even then, the average,
Oh, wait, I know what we need to measure.
measure the max.
Maximum voltage.
Yeah.
Measure the max. The max is 329 millivolts. Now try twisting the knob. Are you twisting?
Oh, it may need yeah.
Oh, no, wait, there we go.
Lowering, okay. Down there, 200. So if I have this maxed out, that's not enough to turn on the transistor.
And that means?
I think the problem's here. Somewhere. So, wait a minute. Has the problem been something here the whole time? Like, has the problem not been the board at all?
Well, here's the thing. What does that transistor do? Does it send data?
Oh, the transistor is basically a switch. So here's the idea about this transistor and what it does. There's a very high voltage that's set here through this resistor. Remember that 3 watt that we thought was bad that turned out to be good?
Yeah, the R103.
Yeah, and so basically when this voltage at the base is low, this transistor is acting as an electronic switch which switches this off. So you'll get a big voltage here, and which will essentially turn off the electron beam. And then if you actually have enough voltage here, then what that will do is it will turn this transistor on. It will kind of like turn it on this way, and it will lower that voltage. And when this cathode voltage over here is low, then you'll actually see a spot on the CRT. At least that's my understanding. So we really need to be looking around here, I think.
Well, I mean, how are we going to fix the transistor if it's busted? We're going to have to take it out
Well,
and
that's what I'm
resolder it?
saying is the transistor itself, I think, is fine. I think there's some problem over here that we're not driving this with enough. Or maybe, is there something wrong with the transistor that it's loading this down?
Maybe we need to check R101. R101 would be my first stop to check. Check the resistance.
Yeah, something. You know what? Let's measure. What I want to do is I would really like to disconnect it here and see what's going on with this pot. Okay, so I've disconnected the monitor entirely, and I'm now measuring the signal coming right out of the contrast pot. And if we look at the scope, that's 100 millivolts max. So I think the monitor and the monitor PCB that we've spent all of these hours poking at may be fine.
Well, I'll be. We should have just measured the port from the beginning, to be honest.
Well, the irony is I did. I just wasn't paying close enough attention to what was actually on the scope. So I just saw a signal, but I didn't bother to look at if you look back at the scope, I wasn't bothering to look at the volts per division. Go up to show the actual signal. So I saw that, and people commented on YouTube that the signal looked a little bit janky. I should have focused in on those comments more because I think they were spot on.
Yeah, Dad, next time when it comes to debugging CRTs, listen to the people who know what they're doing.
Yeah. So to isolate the issue further, I want to go back. I've done this before, but I wasn't paying attention to the units on the scope. I was just looking for a signal. I want to look for the digital signal that's coming out of here and see what the voltages there are like. Because if that's looking good, it means that there's something dodgy with our contrast control.
It was the card.
Okay, so check this out. Here we're looking at the vertical sig signal, which looks like a 5-volt signal.
60 hertz.
And it looks like now if I go down 1 pin to the horizontal signal, that looks like a 5-volt signal, correct thing. Now check out the TTL signal.
What is that?
That is not a proper TTL signal. So, ladies and gentlemen of the YouTubes,
It's the board.
I think I was wrong the whole time. All the time we spent poking over here. Thank you people in the YouTube comments who noted that the video signal looked kind of jank and suggested that I look here at the contrast control. I think that's fine. There's something wrong with the board here.
Wait.
I don't believe that.
Dad, here,
Yeah.
turn to look at the camera real quick and put both your hands on your face like this and make a, like... There, that's totally gonna make a great clickbait YouTube thumbnail, like Mr. Beast.
Oh wait, actually, let me do this. Okay.
Chat, is this real? Yes, that's perfect.
There may still be jank involving the monitor once we figure out what's going on with this card. There may still be issues with getting
Mind your
things
fingers
in
around the
proper
anode.
alignment. Yeah. Oh, good point. There may still be things here that need adjusted. There may still be janky aspects of the image that maybe a cap needs replaced or something. So I'm going to leave this disassembled for now. But next time we come in, we need to start poking at the flash writer card. For that, we can use that extender card.
My father is talking about this thing, which has a nasty scratch on the connection there.
It happens. But anyway, yeah, so we need to actually shift gears to looking at the flash writer card.
Well, I'll be.